Okay, in this video we're going to learn to balance equations. Now what I mean by balance equations is that the atoms, or according to the law of conservation of mass, mass is neither created or destroyed in a chemical reaction. So in a chemical reaction, in essence, atoms are preserved. So the amount of atoms that go into a chemical reaction have to equal the atoms that come out of a chemical reaction. So for example, let's look at this one. In this case, I have two hydrogens that are going into the reaction, and I have two hydrogens coming out of the reaction. That's good. Here, I have two oxygens going into the reaction, and over here, I only have one coming out of the reaction. That means we've destroyed an oxygen. And in a chemical reaction, that doesn't happen. So I'm going to use coefficients in front of the formulas in order to balance the equation. So we always use in front to balance. So in this case, I'm going to put a 2 in front of here. What that tells me is this 2 distributes like it would in mass. So this 2 is going to multiply times this 2. There's understood to be a 1 here, and so this is going to multiply by 1. So in a sense, what I've done is I've got two oxygens on this side now by creating two water. So let's look at it molecularly. So I've got a water, and I've got another water. And by putting a 2 in front of there, I've created two waters, and now I have two oxygens. But I also now have four hydrogens. So then I'm going to have to put a 2 in front of this in order to balance the hydrogens. Now I have a hydrogen molecule, another hydrogen molecule, and they are now going to balance because of this 2. So there's always, if there's no coefficient written in front of here, it's always understood to be a 1. Okay, let's look at another one. This process that I'm using here is balancing by inspection. So I'll clean it up a little bit. And it really is just going to take some practice. And once you practice it for a while, you'll get pretty proficient. So in this case, I'm going to start, and it doesn't matter what element you start with. I tend to avoid hydrogen and oxygen till last. So here is nitrogen, and I've got two of them here, but I only have one here. Remember, this 3 only applies to the hydrogen, not to the nitrogen. If there's some case where it would apply to both, you'd have some kind of formula like NH3 parentheses and then a 3. Then that would apply to the hydrogen and apply to the nitrogen. But we don't have that in this case. There's no parentheses present. So I'm going to put a 2 in front of here. That will now balance my nitrogens with 2. But it also gives me 6 hydrogens. So by putting a 3 in here, I can get 6 hydrogens. And there's always understood to be a 1. Okay, let's do another one. So I'm going to show you several of these, and then you're going to have to practice. Okay, in this particular problem, it doesn't matter what element you start with. Let's pick a different. Let's pick chlorine, for example. I've got chlorine here, and there are 3 of them. And then I'm going to put a 3 over here. Now when I do that, I get 3 hydrogens, but I got 2 here, and you're like, oh, I don't know, I don't like that. So I'm going to begin with a different element. Sometimes changing elements makes the balancing much easier. Let's pick phosphorus. I've got 4 phosphoruses here. Let's put 4 here. That gives me 4 boron. All right, we'll put a 4 there. That gives me 12 chlorines. So I put a 12 there. That gives me 12 hydrogens, and now I can put a 6 here. Understood to be a 1. So by picking a different element, I made the balancing much easier. So if you get stuck with you begin with one element, pick a different element. Sometimes it can make a big difference. In this particular equation, we've got some polyatomic ions going on. And sometimes you can balance by leaving the polyatomic ions alone. Let's pick iron in this case. I've got 2 irons here. I'm going to put 2 here. It doesn't matter what element you pick. That gives me 6 chlorides. So I'm going to put a 3 here. That gives me 3 bariums. Now watch what I do here. I'm going to put 3 bariums here. I'm going to go ahead and assume this is a polyatomic ion. I'm going to keep it together and say there are 3 sulfates total. So I've got 3 sulfate ions. I've got 3 SO4s. Not 12 of them. A lot of students want to call this 12. If it was going to be 12, it'd be SO4 parentheses and a 4 down here. And then you'd have the 3 out here. Okay, but that's not what's going on. Okay, so then I notice on this side I have 3 sulfates. So now my equation is balanced. Again, many times if you have polyatomics, not all the time, but many times when you have polyatomics, they will balance themselves. And you can look at the individual atom. You can look here and see, well, I've got 3 sulfurs and 12 oxygens. Well, I also have 3 sulfurs and 12 oxygens over here. But like I said, many times it's easier just to balance by keeping your polyatomics together. Okay. So in this case, I try to avoid things that are oxygen and hydrogen to last, and it will make this problem easier again. So I, for example, have 2 sodiums here. I'm going to put a 2 here. That gives me 2 chlorides. I'm going to put a 2 here. That gives me 2 hydrogens, which I have. And over here I have 2 hydrogens. That's good. Now, all your oxygens have to balance, and all your hydrogens, all your elements. In this case, I have 3 oxygens here. I have 1 here, or 2 here, and I have 1 here. That's a total of 3 oxygens present. So it's balanced. Even though they're in different compounds, it's going to balance. And then I notice I have 1 carbon here, and I've got 1 carbon here. So remember, these are understood to be 1. Also, I'd like to point out, as you want the lowest ratio of coefficients as possible. So let's say, for example, in this particular problem, you would have balanced this as 4, 2, 2, 2, 4. Oh, messed that up. Okay. 4, 2. This is still a balanced equation, but I can divide this entire equation and not get fractions. So a better answer would be 1, 2, 1, 1, 2. So I expect to have the lowest coefficients possible without generating fractions. Okay, so let's do this one now. So in this case, I have 3 magnesiums. I want to pick 3 magnesiums. I'm going to ignore oxygen and hydrogen to last. I like to do that a lot. It helps balancing. I've got 2 nitrogens here, so I'm going to put 2 here. Okay. Now I'm going to look at my oxygens and hydrogens. I notice that I have 6 hydrogens here. And over here, there are 2 times 3, that's 6 hydrogens there. That's a total of 12 hydrogens on the right side. So if I put a 6 here, that would give me 12 hydrogens. But that generates 6 oxygens. But I notice 3 times 2 is going to give me 6 oxygens. So then my equation would be balanced with the following coefficients. Okay, multiplying to solve. This is a technique that is a must for some type of reaction types and is convenient for other types of reactions. So in this case, I'm going to start with things that aren't hydrogen or oxygen. And I notice I've got 1 nitrogen and 1 nitrogen. Well, now I'm just down to hydrogen and oxygen. So in this case, I'm just going to start with hydrogen. It doesn't matter what you start with. I'm going to start with hydrogen. I've got 3 of them here and 2 of them here. Well, I'm going to have to use a common denominator. So I've got of 6, so I've got 3 times 2, and then 2 times 3. That gives me 6. Now I've changed the number of oxygens, so I've got 3 oxygens here. Oh, let's do nitrogen first. So there's 2 nitrogens here, 2 nitrogens there. Now I notice that I have 2 oxygens here. I have 3 oxygens for a total of 5 oxygens. Well, there's nothing I can put here that would not be a fraction or a decimal, and I want to avoid fractions and decimals when balancing equations whenever possible. But I could put 2.5 here. If you don't feel comfortable doing this technique, I understand. But sometimes it makes balancing much easier. But I can't leave that 2.5 here. So what I'm going to do is I'm going to multiply everything in an equation to get rid of that. So if I multiply by 2, this becomes 4, this becomes 5, this becomes 4, and this becomes 6. So if you ever get a single element by itself, and sometimes you can add a third or a half or some kind of fraction or decimal in order to get it to balance, go ahead and put it there. You just can't leave it there. You need to multiply in order to solve. So this is an example of that. Now here's a situation where you're going to absolutely have to use multiply to solve in order to come up with the correct answer. These are called combustion reactions. And combustion reactions are going to take some kind of carbon-hydrogen. We're going to add some kind of oxygen. You're going to make CO2 and water. You're always going to make the same thing every single time in a combustion reaction for the purposes of this class. So combustion reactions always make CO2 and they always make water. Okay, so the first thing I do in a combustion reaction, if you follow these steps, it's going to make it easier. First thing I do is I balance carbon. I notice that I have 6 carbons on this side, so I'm going to need 6 over here. Then I balance hydrogen. I've got 6 hydrogens over here. I'm going to put a 3 here, and that would give me 6 hydrogens. Then I'm going to look at oxygen. I've got 12 oxygens there, plus 3 oxygens, a total of 15 oxygens. Now, there's no number I can put here that's a whole number that will equal 15. But I could put 7.5. If you don't know, you can take this number and divide it by 2. It'll tell you what number you should put there. The problem is I'm not allowed to leave 7.5. There's understood to be a 1 there. So this, I'm going to multiply by 2. This becomes 2. This becomes 15. This becomes 12. And this becomes 6. Multiplying to solve is a very, very, very common thing to occur in these combustion reactions. So the first thing you want to do is recognize it's a combustion reaction and then realize you may have to use multiply to solve. And if you follow these steps, you'll end up with the right answer. Let's do another one. So in this case, I'm going to first balance carbon. I've got 7 on this side. I'm going to put 7 on this side. Next, I'm going to balance hydrogen. I've got 14 on this side. I'm going to put a 7 here. That gives me 14. And I notice I had 7 times 2. That's 14. Plus 7 equals a total of 21. So 21. Now there's no number I can put here that'll give me 21, but I could put 10.5. Again, you can divide by 2 if you need to. Okay, I can't leave the 0.5 there, so I'm going to put a 1. Multiply everything by 2. This becomes 2. This becomes 21. This becomes 14. And this becomes 14. And now it's balanced. Again, notice I'm just making CO2 and water from some kind of carbon-hydrogen with some oxygen. These are called combustion reactions, and multiplying to solve is a common technique. Okay, so now is a good time to pause the video and then see if you can balance these reactions. And then the next slide will have answers. And then there's another pause the video, and the next slide will have answers. The key to getting good at balancing equations is just practice. Remember to pause the video here. Okay, here are the answers. Okay, pause the video again here. Try to see if you can do these. And here are the answers to those videos.